Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today in this lecture, I'm gonna explain the MPI group communication concepts and the supported functions by MPI like broadcast, scatter, gather, and reduce. So until now in our previous video, we have explained what are called P2P messages. Now the next important concept of MPI is called as group communication. MPI also provides routines that send message to a group of processes or receive messages from a group of processes. Possibly one process sending a message to 10 other processes or 10 processes communicating to a single process. That's known as group communication. Group communication is actually not essential for programming because if you have a mechanism through which you can communicate with one process to one other process, then you can use the same mechanism to communicate between one process and 10 processes. You just have to repeat the mechanism 10 times. So the reason MPI includes group communication is to make things easier for programmers. So it's not absolutely essential, but it makes programming a little bit more convenient. And it may be possible for MPI library to do group communications more efficiently. So let's go ahead and start explaining one by one some of the MPI group communication functions, including MPI Bcast or MPI broadcast, MPI scatter, MPI gather, and MPI reduce. So first of all, let us try to understand what the Bcast function is. I'm going to describe this diagrammatically. If the situation is, suppose we have a parallel program which is running n processes, and processes have ranks starting from 0 to n minus 1. Now each of the process is going to run, let us suppose, on a different processor. It's going to run the same program, and suppose we have a requirement that we want a particular piece of data to be communicated from process 0 to all other n minus 1 processes. This is kind of scenario where we can achieve using a call to MPI broadcast. So at the appropriate point in the program, we would have to include a call to Bcast function so that it's executed by all the processes, and what's going to allow us to do is to communicate a single piece of data, a single data element of address space of process 0 to all other processes with single communication. So with a single call to this MPI broadcast, we have been able to broadcast the value of this, for example, data element to all other n-1 processes. So let's have a look practically on the usage of broadcast function in MPI. So this is a program I have created earlier as MPI broadcast.cpp. Include mpi.h, and then here let us start the program by initialization. Then other stuff will be MPI rank. Here the first argument will be MPI world, the default communicator, and here I'm going to send a variable called as rank as the second argument. So for that I have to declare this rank over here. Let us declare the data element as data equal to 0. I'm initializing it for each and every process. This will be a shared data element, and that means that this data element will be present in the address space of all the processes initially with 0 1 with value as 0. So here now I want to get this data element in a particular process, for example in our case in process 0, and then from process 0, as explained in the diagram, I will be broadcasting this data element to each and every process present in this communicator. So for that, let us have, if our rank equal to 0, then let us initialize this data as 10. So since here this, if we are checking if rank equal to 0 in address space of process 0, this data will be initialized, or this data will, the value of this data variable will be changed from 0 to 10, but only in case of process 0 here. After this, we can display this this data element from each and every process like this before Bcast data in process as, this is process ID, and the value of data. Here will be the rank, and another one will be the data. And after this, I will call MPI Bcast, and here I will be having the first argument as, quickly let me show you the arguments of the MPI Bcast. So first argument will be the buffer, the data element to be broadcasted, and count of data elements to be broadcasted, and there will be the data type of the data element to be broadcast, and then the source process or the root process from which I want to broadcast, and then I will be having a communicator. So these are the arguments we gonna use in the Bcast, MPI Bcast. So first will be this one, the data buffer. Let's go again there. So our data buffer will be, in our case, the data element will be data, and then the count of the number of data elements is 1, obvious. So here we are using the MPI integer because our data element is an integer, and then root process or the source process, that will be with rank 0, and then here will be our MPI communicator. So here at this point in the program, we are broadcasting the data from process 0 to all of the processes. So let us try to display this after broadcast. After broadcast, the same thing, the rank and the data element. Let's quickly save this and build. That's done. So we will copy the path here. And we will change directory and then paste. So here I am going to MPI exec -n. Let's suppose we have 6 processes, and our program name is MPI Bcast.exe. Ignore this stuff because this is an I'm trying to execute the executable file, so my avast on the first attempt is checking and throwing an error due to this. Now second time I will be executing this. So I'm getting this error, MPI Bcast.exe ended prematurely and may have crashed, exit code 0. That means, yeah, I forgot to call finalize function here in my MPI program. So here I'm gonna call the finalize function. Finalize. Hopefully that's done. So I'll build it again and go into command prompt, execute. That's it. So here you can see before broadcast data in process 1 is 0, and after broadcast data in process 1 is 10. And here you can see, you can notice this before broadcast data in process 0 because this is a root process, and before broadcast I initialized the value of data equal to 10 in this step here. If rank equal to 0, and then I have initialized this data equal to 10. So that's why before broadcast the value of data the data variable inside the address space of process 0 was 10. Rest of the processes, how they get the 10 value after this broadcast. When I broadcast this data element to all the processes, so after that when I am displaying it again, so here each process before broadcast except this process 0 has value 0, 0, 0, 0, 0, and after broadcast 10, 10, 10, 10, 10 and 10. That's it for the broadcast function. An additional information which I want to give you here is that in my description of Bcast I told that I mentioned there that we can do the same group communication using point to point. What we have to do is to repeat the mechanism. For that, for example, if we want to handle this situation without this MPI broadcast, so what we have to do is we can send MPI send to each of the processes repeatedly. For example, if we have 10 processes in our system, so I can repeatedly call 10 times the send process over here for the different processes, whatever intended, or else we can use the looping structures to repeatedly call the send function, and the root function will be 0, the sender will be always 0, and the receiving functions and the receiving processes can be 1, 2, 3, 4, 5, 6, 7, and in different calls I will be using the different receiving the destination process in the send function, and the same objective will have been done using the send function also. Okay, now the next function which I will talk about is scatter. Once again we will look diagrammatically. Suppose we have a situation where there is a parallel program running n processes, and once again a single call to MPI scatter is going to satisfy our requirement. Now what's the requirement? Suppose we have a collection of data which happens to be present on, let us suppose, in P0 in a buffer, and we want to distribute the data present in the buffer across all the n processes in the parallel program. To be more precise, if we want the first element of the buffer to be scattered or to be sent to process 0, and the second element to the P1, and so on. Now this primitive operation, what's known as a scatter, and the name makes the sense once we understand what it does. Essentially, we had this collection of data, and we wanted to scatter it across the different processes of any parallel program. In this example, one element going to each of the processes. So if we look at the arguments of the scatter, it should mention both the data element and the buffer to be scattered for that particular process, and also the rank of the root must be included. So here will be our send buffer and the count, and send type, receive buffer. This is the data what I have mentioned in the diagram, and here will be the receive count, the send count and the receive count, and then receive type, it will be some data type, MPI data type, and here will be the source process, or which is also called as root process, and our communicator. Let us start programming the usage of MPI scatter function in MPI. So this is a program I have already created over here, and I have copied some common things in all the MPI programs like MPI init and MPI com rank. And here in this particular example, we will need integer data. So in this case, this data will be present in address space of all processes, and let's initialize it with 0, and we will be having a buffer. Let's consider this implementation now, and this buffer, for each process I will be initializing this as null for simplicity. Okay, so here let us suppose our root process is again process 0. So if rank equal to 0, so I'm going to have an integer type of array composed of 10 elements, and I will initialize it as 1 to 10, and in the address space of rank 0 I will be initializing this buffer, this variable, to this ARR array. So let us suppose this is the process 0 is getting the array from some source and then assigning that array to the buffer. So this means that these elements are only present in the process with rank 0. Now let us see the variable data, contents of variable data, before scattering our array to all the processes as data before scatter in each process is, and here will be the rank of the process rank is data. Okay, that's so. Let us call our scatter function MPI scatter. First argument, as we can see here, is the sending buffer, and then the count, and then the type, and then receiving buffer, count, and the type, and then afterwards will be the source process. So our sending buffer will be buffer, because it's a pointer, so no need to mention ampersand, so it will be the reference, so buffer, and then we will be having the send count and MPI data, MPI int, and then the receiving buffer, it will be our data, and then count, then same MPI int, and then the root process, and this is the root process from which we are scattering the collection of elements. So here will be our communicator, MPI convert, okay. So after calling this scatter function, let us check the data after scatter in process this and this, and then finally we will be having an MPI finalize. Let's quickly build this. It's done. So here okay, this is the path, MPI scatter here. So MPI exec minus n, so let it be, the number of processes will be 6, and the name of the program will be MPI scatter.exe. Let's ignore this and let's see. So this is data before scatter in process 4 is 0. Let's have some formatting in this so that it will be very easy to understand. So here I will have a new line. Save this and build this again. So we can check now very clearly that data before scatter process in process 0 is 0. This is the data element, because we are not here, we are initializing the buffer with this array. So even the data element, this data variable in process 0 will be 0, and data after scatter, because we are scattering it here, so we are sending the 0th element of the array to process 0 and 1 to process 1 and so on. So here there will be data before scatter in process 1 is 0, and data after scatter in process 1 is 2, and similarly data before scatter in process 5 is 0, and data after scatter in process 5 is 6, and similarly we have data process 4, process 2 and process 3. So that's all for this scatter process. scatter function. So let me conclude this part of the lecture up to MPI scatter by considering the length of the video and other constraints. Let me make a second part of this same video in which I will be explaining MPI gather and MPI reduce. Thank you for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.